All right, welcome back. We are OOP3200 in the fall 2020 semester, Object-Oriented Programming 2 at Durham, and it's week 7, part 1, probably only part of our broadcast. Today we're going to be talking about a couple things, but the main topic of today is the C++ Standard Template Library, or STL. Kind of covered a little bit of this in an earlier lesson. We covered vectors, but today we're going to go a little bit further and cover a couple of additional template classes. So again, for this week, we're covering C++ STL. There's going to be an in-class exercise 6, which we're doing today. So please, like I said, download that from DC Connect. If you go up online on week 7, you'll see a couple of things here. You'll see that the lesson 7 PowerPoints that are up here. You'll see the in-class exercise 6 Dropbox. So this is, let me just edit this in place for you guys. This is your submission for in-class exercise 6. And I think most of you know what this is. So it's the submission area. This is your starter. So this is your download. It's a zip archive. Please unzip this in order for you to use it. Okay. I've already started, I've referenced this recording on YouTube. So if you need closed captioning support in real time, please click this link so you can watch me on YouTube instead of on Zoom. There's also going to be a quiz. The quiz is on inheritance, polymorphism, collections, and generics. That is right here. You can take that quiz. It will end on October 25th at midnight. That's this Sunday. So that's when it's due. As well, there is our C++ Lab 5. The details to the lab I will go over in a few minutes are here. The starter package is here, and the submission Dropbox is here. Again, this lab is due on Sunday, October the 25th, the same time as the quiz. And then it's to be done in your groups, in your groups for C++. Remember that after this session, we're going to be into our mid-semester break, and we'll talk about that in a second. Let's get back to our schedule. So this is what's happening. So again, in-class exercise 6 we're doing today. Quiz 2, this is due Sunday, right, at midnight. So make sure you get that done. There are no extensions for this. If you don't get it done by Monday, it's 0, right? C++ Lab 5 is also due Sunday at midnight. Make sure this is a group assignment, that you get your group members to do this with you. All right, and this is our schedule. So we're sitting here at the bottom of the first half of semester. After today, we're going to be completing the C++ module. And we'll be moving into the Java module, which I talked about a little bit last week. In preparation, I also asked you last week to go download Jetbrains Intellij IDEA. So if you go to jetbrains.com, like I said, please do this in preparation for next half of semester. Again, if you look at tools and if you look at Intellij IDEA, that's the one you want to download. There is a community edition as well as a pro edition. Remember, as students, you have access to JetBrains, all the pro stuff, just by registering as a student. And you can look at education.jetbrains. If I go education, JetBrains, then there is free educational licenses, like I said, for students, where you'll be able to access all the pro features of and all the pro tools, including Resharper, C++, and so on. You'll do all that, by registering yourself as a student. It doesn't take long. They're pretty quick to reply. So make sure you do that. In addition, you can't run Intellij IDEA with Java without some kind of Java downloaded. So you need to download Java. So the Java SDK. Okay, so that's the thing you need to do, or the JDK is what I meant. So if you notice, Oracle has the Java SDK or JDK ready for you to use. Just a note that it is now considered, even though it's free to use for you, the JDK download is proprietary now. It belongs to Oracle, and there's a big kind of fight going on between Oracle and Google, as Oracle is trying to claim damages for Google's use of Java for their Android operating system. So it's kind of a big thing. And you can also look, if you open, kind of look for Open JDK, if you say Open JDK, that is also something that is out there. And I kind of showed you this last week. The Open JDK project allows you to use Java as an example, you know, kind of in an open source way. So there is Open JDK, you can use this as well. You need to have this set up on your system in order for you to use the thing that we're going to be doing next, which is, like I mentioned before, IntelliJ IDEA with Java. We'll do a whole setup and everything else when we get in after the break. But in preparation, please download, register for your free educational account, download IntelliJ IDEA, install your Java JDK. You must have this downloaded and installed, or else your system will not support Java programming. And then you'll be ready for what we're going to be doing next in the next half of semester. Any questions around this before we move on? I'm bringing this up. It's a piece of admin, and you need to have it ready, because when we get together in the first week back, which will be, I guess, week 8, next week is considered a break week, then we'll be running right into it, and there won't be a lot of time for us, as normal, to get Java installed. If I can, what I'll do is I'll put together a little PowerPoint to help you with installation instructions, right, just to get you going. But there's lots and lots of tutorials on YouTube and everything else to get you going as well, just to get your stuff installed. That's all I'm asking for, not for anything else. Okay, so please, if you haven't had a chance to look at this already, please start looking at this before the next half of semester. All right, so again, we're sitting at right here at the bottom part of C++, and as you can see, this week, just like week 3, is a big week in terms of waiting for marks, right? So again, there's 3 different things you have to submit. In-class exercise is going to be due by Friday. Your C++ Lab 5 is due Sunday, and so is your quiz, just like I said before. Okay, questions around this stuff, the outline, and what's going on for the next half of semester. Luckily, we have a reading week. There are some colleges that are not doing that this semester because of COVID, and you know, woe be to them. They're going to be kind of pushing through with the stuff that they're doing, and their students aren't getting a break. You guys are, well, more of a break than the other people are. Okay, let's go to the next half here. So today we're going to be talking about the standard template library, linked lists specifically, a little bit of stacks, a little bit of queues, and I also got to include maps here, because that's something that we're also going to be covering in this semester, and this time around. I'm also going to be covering. I've also included at the bottom of this, because it's going to be useful for your assignment. I've also covered things like an addendum that has basically file operations that include reading and writing, because you may have forgotten how to do file operations. I'm not sure if you remember them or not, but I wanted to make sure that you know how to do that. So I included a couple of examples, code snippets that you can use to help you guys do it. We didn't have one last semester. You mean a break, mid-semester break? Yeah, I know. It's pretty tough, Nicholas. It's pretty crazy. All right, so let's cover the concept here. So again, we talked about the standard template library last time. What is it? It's a group of functions and container classes that have been successfully created, and these are being used for the majority of C++ programmers out there to get going. Sometimes they rewrite some of the container classes and some of the STL itself because they want to make it more efficient. And the reason for this is because some of the functions are maybe a little bit fat. Some of the classes are bigger than they need. And then what they do is they create their own so that it makes more sense. But for the most part, the STL is a great place to start in terms of functionality and general algorithms that you can use for your code. So there's two types of container classes we're going to cover. One type is sequential containers, and the other one is associative containers. Excuse me. We've already kind of covered a sequential container, like we talked about. Actually, two. Covered arrays. You should know about arrays from last time you touched C++. As well as vectors, which we covered together. Right? So they're both examples of sequential containers. Today, we're also going to be covering associative containers, and excuse me, the one we're going to be covering is called the map. And I recommend the map function for what you're going to be doing for your lab 5. Okay. Sorry. So because a sequential container organizes the items it stores in a sequence, sequentials, right? You have something called a front and a back a lot of times, right? For vectors, we usually only have access to the back. Sometimes not all containers give you access to both sides. Okay, so that's one thing to note. So arrays and vectors are examples of sequential containers that provide random access, usually through some kind of subscript operator. All right. Excuse me. Associative containers use key value pairs. That's what they do. And a good example of an associative container is a dictionary or a map. It's amazing. You know, I wasn't talking for so long, and suddenly, as soon as I start talking, I got to drink water. And everything else. I'm not sure why that is that. It was pretty good until just now. Okay. Woohoo. Let's keep moving. All right, so a map is a good example, like we said. There's also something called a multi-map and a set. They're different kinds of associative containers, okay? And usually what we do with associative containers is, thank you, associative containers is that we have a key, and the key points to a value. Usually the key, I mean, it can be of any type, all right, as an example, but a lot of times we use strings as keys. For example, I might make a friendly name for the position of an item in the associative container. I use this a lot when it comes to game programming a lot. Let's say, for example, I want to have a texture for my game object. And think about this. I have some kind of player object that I have in the game, and it looks like a spaceship, right? Well, instead of indicating the spaceship with a subscript reference, like 0, as an example, 0 is really, not really informative. I'd rather use, in quotations, ship, and the ship would be the key. The value would be a pointer to the structure, all right? So that's how it works. Excuse me. We also have something called iterators, and iterators are part of all containers in the STL. They behave like pointers, and what they do is they basically point to a part of the container that you're looking at. They're used for accessing elements in the container and returning back values. They're also used to check to see if the container has anything inside of it, or if you've reached the end of the container. A good example of that is the end method. The end method is a built-in iterator, right? It's a method that is contained in all containers for the most part. And the end basically says it's just past the end. That's what the end iterator looks at. So it can check to see if the container is non-empty. That's what it's really used for. You can also use the end in your looping functions to check to see if you've reached the end. Okay, that's how we do it. When we iterate through a container, it's not like as easy as iterating through, as an example, an array sometimes, especially when it comes to something like a map, right? For a map, there is no necessarily, it's random. the way it is. You can certainly use the subscript operator, the square brackets, to access elements in the map, but a lot of times what we want to use when we iterate through, especially if it's a dynamic container like an associative container as a map, you want to use some kind of for in or arranged for loop. And for that we can use our iterators. Excuse me. Here's an example of an iterator. Let's suppose I have a vector that's of type int. Okay, so again, remember in the angle brackets, that is the class type, if you will, or the data type. We can also use our custom data types in here. So whether it's a vector or a list or a map, we can put our custom data types or our standard data types in there, our primitives. So here's an example of an iterator. Okay, so the iterator is an object that belongs to class vector. That's what it belongs to, right? This iterator is an object that belongs to class list. List and vector are part of the STL library, okay, the standard template library. So as an example, when we declare a vector of type int, we call it, let's say we call it vector vect, and a list of type string, which we call mylist. Then we can make an iterator, for example, vint, viter. Viter would be an iterator type, and it points to the vect begin, the beginning of the vector. So the top of the vector, right? The first element in the vector. And you can do the same thing for the list. You can make a list iterator that points to the beginning of the list, okay, as an example. We can also use, after C++11, and it's highly recommended that we can use the auto keyword, that uses type inference to determine the type of the iterator. For example, if I have an assignment like vect.begin, and we call our identifier viter, and if I put the auto keyword in front, the auto keyword will determine what the type of viter is by the thing that's assigned to it. Okay, and that's kind of a good way of doing it for iterators, because imagine if I had to put in front that other stuff, it's more difficult for me to do something like this, as an example, than for me to do something like this. And that's why we use it. It's kind of a good practice. Okay. There's also something else we can do as of modern C++. What it allows us to do is pass in parentheses the container, as an example, that we need the begin and end functions for. For example, I could say I want to use begin, but I want to make it for the vector, a vector type, the vec that we declared, right? So again, you can combine the auto inference, right, keyword, as well as this syntax to point to the beginning of the vector called vect. Okay, so that's another way of doing it. All right, so that is pretty much just an idea of what iterators are. And iterators are great in terms of you can do iterator plus plus as an example. You can increment or decrement iterators. You can also use the star iter to represent the element that you're looking at. All right, so this is a dereferencing operator that allows you to look at the element that the iterator is pointing to. Okay. A good example of that would be, let's suppose I have a vector vect with elements 10, 20, 30, 40, 50. I can make an iterator that's of vector begin, as an example. Here's a while loop. While iterator is not at the end. So while I'm not at the end of the container, right? Loop. And every time I loop, I'm going to say, okay, let's print out the value of the thing that iterator is pointing to. And now let's do an iterator plus plus, which is going to increment the iterator, the pointer. It's going to act like a pointer and move the iterator to the next value, and the next value, and the next value in the loop, which is pretty cool. So that's how you would loop through using an iterator. Okay. The STL has a bunch of different kinds of containers. Here are some that are listed here. And here's the classification. As an example, you can see that these are sequence containers. And these are associative containers, like we talked about. Okay. Inside the when it says use, how do we use them? A vector is kind of like a dynamic array. A list, we use them as a linked list a lot of times. A deck, we use for stacks and queues. We're going to talk about decks really quickly. We use sets for binary trees. Multiset, again, a set has unique values. A multiset has values that are not unique. A map and a multi-map. And a map, again, it uses kind of a binary tree, and we have a unique key that doesn't permit duplicate objects, whereas a multi-map, you can have a unique key that permits duplicate objects. Okay, so there's different things like this. There's also an unordered map, because in the back of a regular map, it's an ordered map, a sorted map, and it's a little bit fatter and less efficient in some ways. If you don't need a sorted list, then you can use an unordered map, which is a little bit lighter in terms of the way it works in the background. Okay, we're going to talk about these today. So again, there's the list type, and again, there's two types of lists. We can have a sequence list, a list object determined by its position in the list, and associative list, automatically maintained in sorted order. Okay, those are the two types of lists. Arrays and STL lists are both referred to as containers, and we've talked about this before in collections. In your quiz, you might get a question like this, and I recommend for the quiz, before you do the quiz, because it is worth 5% of your final grade, and it's a multiple choice, true false kind of quiz, that you have you study your PowerPoints. There's not a lot of time to kind of do your quiz, so make sure that you kind of have your PowerPoints ready, and then you're able to reference them, and at least you've looked over the stuff that the quiz is covering before you do it, so you have a higher chance of doing well. So a lot of times we use lists to store records, and here's an example of adding an object to a list. We instantiate an object, whatever that object is. Maybe it's our custom object, like a vector. We're going to talk about something like that today. We're going to add it to the list, and it's dynamically added to the list. Right, so it's not like the list has necessarily an ordered sequence. It's random, right, and it allocates memory for the object. As an example, similar to what we do with a vector. Okay, we talked about iterators, and again, some of the most common used lists are linked lists, stacks, and queues. I want to mention that stacks and queues, these structures don't really exist with C++. We need to create stacks and queues using something called a deck, and we're going to talk about that. So notice when I went back here, there was no stack or queue as a type, right, of list, right? We said instead that we're going to use something else to look at that. So we could create these stacks and queues, right? Here's an example of a linked list. A linked list, and something that you're going to hear a lot about. Again, we create a linked list. That's what we use lists for a lot of times. What we have is we have a record. Let's say, for example, this person here, and then the address of the next record is at the bottom of the nodes. We have different nodes, linked list nodes, and each list nodes points to the next list node, and so on. And so this way you can iterate from one node sequentially to the next one. Okay, that's kind of what a linked list is. This is a single linked list. You can also have a double-ended linked list, which you may have a node that points back as a structure to the previous node. So a double linked list, right? More complex structure. Linked lists are used a lot for all kinds of things. And in the back, as an example of a vector, there is an implementation in some ways of a linked list. We talked about the pointer variable, and here's an example of how this would work. So again, if we're going to create a linked list, I'm just talking about structures here, guys. Okay, I'm not talking about that this exists in the standard template library. Again, I have the address of the next person. Let's say, as an example, it's pointing to this address over here, and then you can see that the next address here is, pointing over here, and so on. So this is an example of a linked list. It's just the way it's been written is weird. Okay, I'm just going to keep going here so we can talk about the structures that you need. Major benefits of the list class can be constructed without the programmer having either to understand or program the internal details of the pointer variables. You don't care about this kind of stuff. The list itself takes care of the details itself. Instead of you constructing each of the nodes, the list itself, which is a linked list on the back end, takes care of it for you. All right. I'm just going to move on, because this basically talks about the same kind of thing. I just want you guys to know about what a list is, not necessarily implemented here while we're looking at the PowerPoint. That's kind of a boring way of doing it, right? So, but here's some examples. So there's an example of code. Again, here's a list of names, the list of type string. So we can say it's a string list, and there's two lists here, names and address names. Okay, those are the two lists that we've created. As soon as we declare the container, we create the container, right? And then we can use the push operations. We can say push front $Edith as an example, which inserts the name $Edith at the front of the names list. And then we can say pushback Lanfranc John as an example that pushes or inserts the record at the back of the names list. Okay, so kind of you can insert either in the front or the back. And here's add names or address names, push front. We can push all these to the front, and what happens is when you push to the front and then you do it again, the one that was in the front goes behind the one that's in the front now. Okay. You can also use sort operations, which are built into lists and as well to vectors and other containers that allow you to destructively sort the list, which means that it will be modified. You will actually modify the thing that you're sorting. Okay, so be careful about this. Once you do this, it doesn't return a new list like you would expect. It actually sorts the list that has been created. Okay, so be careful about this. All right, so that's the list class. I've also inserted another code snippet of another list example just for your viewing pleasure, right? Because we don't just have lists of type strings, but we can also have lists of type integers or any other primitive type or any other custom type. It's up to you, right? So here's an example. We can push to the front and push to the back. We can use a sort as an example, and we can also use, here's an example of a vector. We've talked about vectors before. A vector of ints that are kind of instantiated with 2648, right? And then we can take other values, which is a list, right? And I can look at the beginning as an example, insert from the beginning, right? That's into the beginning, from the beginning of my vector until the vector end. This is kind of a really cool insert function that works with lists. So lists have really awesome insertion capabilities where you can take an existing container and insert each element of the container into the list. So from a vector example into a list, which is kind of cool. And there's other operations like splice and a bunch of stuff that we won't have time to cover today. But you should explore it if you're interested in using a list structure. Stacks, again, is something that we're going to be creating with the deck class. So what does a stack look like? I want you to think about a stack like a stack of cards, right? Or a stack of plates. And the way stacks work is that it's last in, first out kind of structure. Last in, first out, or LIFO. So imagine if I put a card at the top of the stack, as an example, or a stack of dishes, like they talk about here. If I put a card at the top of the stack, when I take a card off the top the stack, as an example, what I'm doing is I pop the card off of the stack. When I push a card onto the stack, it goes to the top, right? So again, last in, first out is the way the stack works, right? And actually we use a stack for programming, right? Every time that you want to, you're calling a function, you push a reference to the function in our call stack. That's what we have. So we push a reference to the function on the call stack. Then the compiler will execute that function. When the function is finished executing and the scope has been completed, it's gone from inside the code block, then it's going to return to the stack and pop that calling function off of the stack and go to the next call below that, as an example. And the way we can have Stack Overflow is we can run out of memory. We can keep on putting functions on top of the stack, keep on pushing functions on top of the stack until there's no more room. How can this happen? A real common way of Stack Overflow, and this is where the Stack Overflow name came from, right, is using recursion. If I call a function from itself, I keep on putting a copy of the function onto the stack, and I keep doing that over and over again, right? And before it has a chance of popping off the stack, there's no more room, and so we've Stack Overflow. Another way to do that is some kind of looping structure that calls a function over and over again. Every time we call the function, we put it onto the stack and we can get a Stack Overflow. So, so here's an example of a stack of 3 names. As an example, we can add a name. We push a name onto the stack, it goes onto the top of the stack. We push another name to the stack, it goes onto the top of the stack. When we pop a name off of the stack, it leaves the stack, the top name, it's gone. And we keep popping off in this kind of pyramidal structure. So we kind of go over here and we start off with this. This is kind of our, think about this as a deck of cards or a stack of plates. We're always going to take the top plate or the top card off. So that's again last in, first out structure. And here's another a way of looking at this, right? So again, we can push a number onto the stack. We can push another number onto the stack. We push another number onto the stack. When we pop it off, we pop the top number off every single time. Again, there is no stack, so we can use something called the deck class, right? Queues are kind of the opposite of stacks. Queues are like lineups. Queues are great. If you're going to line up for the ATM, it's first in, first out, or first come, first served is kind of what we look when we look at queue structures. And you kind of should know these structures from other courses. So again, I line up for the ATM. If I'm the first person in line, then I get to use the ATM. And people line up behind me. So again, first in, first out. So the last one in has to wait. Last one in, last one out kind of thing. That's also a way of thinking about stacks, or queues, I mean. We can also use queues for things like traffic simulations, right? We have a bunch of cars and they're going to an intersection. The car in the front, before it leaves the intersection, it's first in, first out. It's first, the first car, let's say at the stop sign or at the traffic light. And before it leaves the intersection, it's going to be the first car out of that lineup, right? And you can think about that part of the intersection as a queue. Cars are lining up to go through the intersection, okay, as an example. Okay, and again, we want to use the deck class for that, where we can use push and pop in the deck class. And we can do things like, it's similar, on queuing is similar to pushing onto the stack and moving off. I'm going with ATM queues and card stack. Okay, very cool. So let's take a look at the deck container. It's a sequence container. It's not a associative container at all, right? And what it looks like, it kind of looks like this. So I kind of declare, first of all, I include the deck definition, so the include. Then I declare a deck of values, right? A deck is a double-ended queue is what it is. So it's a great way of creating a stack as an example, or a queue. You can push to both sides, so push to the front or push to the back. You can also pop from both sides, right? You can pop from the front or pop from the back, right? So as an example, if I want to pop for the front because it's a double-ended queue or a stack, you're always going to pop from the front as a queue or a stack, right? We're always going to do that. So think about that. So I push onto the front or I push onto the back, depending on the type of operation I want to do, and I just pop from the front all the time. So again, if I push onto the front, that is more of a stack structure. If I push onto the back, that is more of a queue structure that I'm creating with a deck. Okay. All right, so pretty cool. We can also call them, a lot of times when we use queues, sometimes we use the words on queue and dequeue, right? We want to on queue something and dequeue something. In C# you have that kind of functionality. Okay. Maps, and we're going to talk about maps a lot more today because, again, your assignment is going to be using maps. I recommend. The map is an associative container that holds key value pairs, like we talked about before. In the back end, it's created using a balanced binary tree graph. So to use a map, we need to include the map header, right? And when we declare a map, we define it, we say something like standard map. The type 1 is the first type, is the key, and the type 2 is the value. So this creates a pair. That's what it does, okay? A pair of values. And then there's the map name, okay? When we want to access a map's values, so here's the way we declare it. So here's a standard map of int chars, right? So integer would be the key, the char or the car, depending on how you want to say that, is the value, right? And when I want to access the map, you can use the element first or the element second. So element first, the first method or a property of any map indicates the key, and the second property of any map is the value. Okay, that's the thing that's stored inside of the map. Okay. You can also use the subscript operator to access the map, and again, what you would say is the key goes here. If it was an integer, you would just put 1, 2, 3, and so on. If it was a string, you'd put the name, the friendly name associated with that particular value. Okay, here it's the other way around. We have a key, which is an integer, and then the value, which would be the character. And notice when I'm using these characters, an interesting thing is the key does not exist. So there is no 1, 2, 3 in a map. It's not ordered necessarily. I can make these values anything I want in any sequence I want. I established, notice there's no map 0, right? It's not like that. It's not a zero base list or something like that, or a 0 indexed array. It's not like that, right? What it is as soon as I declare an object that I want to put inside of a map, then it gets created. So the map itself, the key does not exist until I associate a value with it. That's kind of something that's different than you've seen before. Here's an example when I want to iterate over a map. I use some kind of ranged for loop where I use the auto keyword to try and figure out what the element is. Well, the element would be a inferred type based on my map. So if my map, as an example, was a map of int chars, so then element would be an element of type int, right? So that would be the key that you're looking at, right? And then what you want to look at is element first and element second. Element first and element second would kind of output those values, okay? You can also do insert. If you want to insert into a map, you can use the insert key, method. Here, what we're doing is, notice that there is an object that we're inserting, and in curly braces, you have to put in the key and the associated value. Okay, that's how you would insert into a map. So kind of a neat way of doing it. Okay, and then you can print out the map. You can see that the map would change. So that's the one thing that we're going to be using a map today with our lab, like I talked about. Okay, and if I want to find a value, I'm showing you this stuff so that it'll be easy for you guys to look to kind of find values and search for values inside of a map. Okay. Yes, so Nicholas asks, so values would have to be, the keys in a regular map unless it's a multi-map, a regular map, it would have to be unique values. So the key itself has to be unique. Every time, if you actually assigned another value to the same key, it would overwrite the previous one. And that can be a source of memory leaks, if you think about it. If I have a key, and let's go back to my game object example. Let's say my game object is called ship. So that's my associative key. It's a string, right? But inside the map, I have a structure that is, let's say, a game object, which is a pointer, right? And so I associate the map with a pointer, and then I assign another object into that particular as an element of the map. So I keep the same key, but I change the value. Guess what happens to that pointer? It's gone. And what ends up happening is you have a memory leak. You have a piece of memory that you have no longer any access to, right? So what you're supposed to do first is delete the object that the key is pointing to, and then after you've done that, then you can reassociate that value with a new object. Okay, that's the way it's happening, right? So it's one of those. It's pretty terrible. So be careful about when you're using raw pointers with maps. They can be quite tricky. Notice that we're using here Iterator. So here's the Iterator, right? IT, right, obviously is an iterator. That's what we're doing here, and we're using map find, right? I want to find a value, or the key that's number 2, right? That's what I'm looking for. I'm looking for a specific key in a map, right? And I'm saying if my iterator is not equal to my map.end, right? If the thing that I found is not equal to my map.end, which means I found it, then I'm gonna show that I found it, and I'm gonna say that the iterator, the element first, that's the key, and element second, that is the value. Okay. However, if I didn't find the map, the object that I'm looking for, let's say I'm looking for number 2. Let's say I was looking for number 4. 4 doesn't exist as a key inside the map, then I would come into this part of the conditional. Okay. So just making sure that you know how to do that. It's going to be useful for you for your assignment. There's a bunch of common programming errors that it talks about here. Inserting objects instantiated from different classes into the same list. I just talked about one of them. Because what ends up happening is you have memory leaks. The 5 most common programming errors related to linked lists is not checking the pointer provided by the new operator when constructing a non-STL list. So if you're making your own type, right? If you don't check the pointer, not correctly updating all relevant pointer addresses, that's really bad. Forgetting to free previous allocated memory. Again, this is a common thing for all containers. If you don't free the previously allocated memory, you're going to have a memory leak, right? Not preserving integrity of addresses contained in a top of stack pointer. Okay, fine. And not correctly updating internal record pointers when inserting and removing records. So you can see that whenever you're making your own linked lists and stuff, these are potential programming problems with that. Here's the summary of what we've talked about so far, and I've included for you some examples of file operations that you're going to need. That's why I put these in here. That's why there's an addendum for what we're going to be doing in your lab. Let's talk about the lab really quickly before we get into our in-class exercise. So, what is this lab asking you to do? Again, this is C++ Lab 5. It's due Sunday, October 25th, like I said before, at midnight, value 6%. It's covering the STL overview. In this lab, you will implement the standard map. That's why I covered map. To store data read from a text file. That's why I added the addendum, right? The data itself is a number of labeled or keyed vector 2 points. So here is, we're going to kind of play with this. I've already given you a structure for this, but and I'm going to look at the template that I've given you. Let me just do that right now. So if you open it to the template, if you have a chance to do that. So let's go into Lab 5. I'm going to look at the Lab 5 starter. This is what you start with Lab 5, guys. Okay. So you start with a main. Inside main, I've given you some hints, some declarations. I've put this try catch in here because you're going to have to also use some exception handling for what we're doing. You're going to read your labels and points into the map, right, as an example. Then you're going to determine the total distance between all points in order. Okay, this is kind of a thing that you have to do. You're going to determine the distance between the start point and the user selected point, whatever you decide to look at. And then you're going to be doing some exception handling. So this is all kind of reminders of what to do. And I've kind of put together a little structure for you just like this to help. What points am I talking about? Well, you're going to be using the class we made together, the template class vector2d.h. Okay? Remember that vector2d.h, I successfully finished this for you from last week. So if you looked at the header files, vector2d.h is a template class. Okay, that means you have to, when you declare a type of vector2d, you have to specify what type it is. Is it a float? Is it an integer? What type is it? Okay, it's not our Cartesian point anymore. And like we mentioned before last time, there's a lot of operations that are already done for you. There's the vector2d class is pretty complete, I would say, okay, for you. And this is a good thing. And the reason for why this is a really great thing is because when you go through here, you can see that there's nothing really for you to do. It even has kind of an out operator and an in operator all pre-overloaded. And it's just one .h file that you have to include, which I've already done for you in your main.cpp. So there's your main.cpp here. One thing to note is you'll be asked to do distance calculations. Right? That's one thing that you'll be asked to do. Well, you can do that with a static built-in function that I gave you called distance. You don't have to make it yourself. All right? So all you would do in order for you to call this function is call the name of the class, vector2d, the type. Let's, for example, say it's of type float, right? And then the first vector and the second vector. And it'll spit out a floating point number to give you the distance between those two vectors. So you have a mechanism to do this. Worst case, let's suppose you want to do it in another way. You can always use my math library, which I've also included here. So I've kind of given you a math library that can help you kind of determine other things. I don't recommend it. I think you'd have to make your own structures, and there's no need for you to do it. All right. So I recommend using the vector2.h distance method. Right? So again, you would access it by saying something like, if I was in main, I'm just giving you an example, I would say something like, hey, vector2d, I want to look at the distance. So vector2d distance, and I want to pass in two vectors, right, as an example, right? Maybe one new vector and another new vector. So a vector2d, as an example, that is of type float, right? And I want to pass in a floating point number of x and y values, let's say. So I would say this, by the way, this is not the in-class exercise. I'm just showing you what you could do with the distance calculator. So let's say I want to get from 3, 4 as an example, and another vector2d of type floats, where it's going to go from to 10, 20, right? And you have to indicate the vector2d of type, because you have to do that too. So vector2d of type float, you want to get the distance between these two floats. That's how it works, right? And then what this is going to do, the distance is going to return a float out to this. So you can say auto distance is equal to that. And if you hover over distance, it tells you it's the type of float. If I want to print this out, right? Let's do that. So let's say let's print out the distance, right? And we'll do it. We'll use the standard toString method to print out the distance. God, typing is not happening today. Oh, there we go. All right. So if I was going to run this little main right now, it should work, right? There should be no work for you to do. If I was to run it, it should just output the distance between these 2 points, 17.464249. So that's how you can use it. I'm showing you here, and I'm recording it for you because you're going to have to do this over and over again for each of the the points. Now, where are these, the data files? Where if you look underneath the data files filter, I've made them available to you to look at. Here's point data.dat. That is the file you're going to use eventually. Notice that there is an association. And what type is this? It's integer types. That's what these are. They're integer types for the points. They're not floating point types. So in this case, if I go back to main, then I could specify I want a float of vector2d of type ints, right? So I want to take a vector2d of type ints, and I wouldn't specify floating point values here. I would say 3, 4, and 10, 20, right? And I'm going to get a floating point value between them, but I'm going to get some truncating numbers happening because guess what? These are integers and I'm trying to get a float out, right, from them. So if I run it, right, again, you're going to get 17.46249, but be careful about this number, right? That's the actual difference in points, whatever those points are. Still works, totally works fine, and you can pass in integers or doubles or whatever you want in there, all right? So that's an example of it. So your point data.dat file, which is this file right here, I've given you access to look at it. Please don't modify it here. This is the point. This is the file that I want you to use. Everyone should use the same file. And so I can, when it comes to marking, I'm going to mark you based on what you have here. Notice that there are key value pairs. Here's the key. Here's the value, right? Key value pairs for this thing. There's also a smaller file that you can use to test with called mockdatafortesting.txt with a smaller range of values. So you can try doing this first, making this little list work before you get into the bigger list. Okay? Let's go back to that for a second. So again, you're going to use, implement a standard map, right? Again, to read text from a text file. That's why I also included the read and write operations. Maybe you've forgotten how to do that. Instead of looking it up, I've given you examples at the end of the PowerPoint. The data itself is a number of labeled or keyed vector2d points. Example, the first point is 0, 0 and is labeled AA. AA would be the key, 0, 0 would be the value. Okay, subsequent points are also labeled with 2-letter uppercase key. Your first task is to read all the labels and points from the data file and then report to the user how many points there are. Well, that's pretty simple. I'm going to go through the entire list, load everything in, and find out how many I have, as well as the total distance between all the points in order. In other words, the distance between AA and AB, and AB and AC, and AC and AD. Okay, that's the kind of thing. So if we look at the file, and if you look at the points, what this is basically saying is, I want to notice that the points here are not in sorted order, right? What do you need to do when you read it in? Sort it. So get it in, sort the list, and once you've sorted the list, then you can do things like in order of the key. So AA, and then you're going to go with AB, and then AB, and then AC, and so on. Okay, that's how it's going to be. All right, so there's some trickiness to this thing, but you guys can do it. All right, your second task is to prompt the user to enter a label, so the key, and then the key is, if the key is in the map, report the distance between the point, that point, and a starting point. For example, AA, which is 0, 0. So what's the distance between 0, 0 and that point that you mentioned? You will continue to allow the user to enter in labels until they want to end. And you can listen for, let's say, for example, the quit entry. All right. Things that you've been provided: vector2.h, pointdata.dat, and mockdatafortesting.txt, plus my little starter project, so you don't have to make your own. Okay, we're using Visual Studio 2019 for this one. All right. So part 1 is reading labels and points into the map. It tells you what to do here in terms of reading labels and points and how to do that. That's worth 20 points. Determining the total distance between all points in order. Okay, so it says use an iterator. We just talked about what iterators are, and a loop to traverse each label / point key value pair, right? And for each label point, determine the distance from that point to the previous point or the next point, depending on how you implement this. and add that distance to the total. All right, so the total distance between all points in order. So from one point to the next point to the next point and so on. Okay. And note that the Vector2D class includes a static distance function that we talked about before that you can use to determine the distance between two Vector2D objects. So you don't need to use anything complicated here to do it on your own. Determine the distance between the start point and a user selected point. Okay, and when the user enters quit, as an example, they can stop entering values. And then there's the last part, which is exception handling. Catch any standard exceptions thrown, report to the user that a runtime error occurred, and show what exception was thrown. This is only worth 10 marks instead of 20. And here's some example outputs. The data file did not open. There should be some kind of exception. The data file opened, but nothing was read into the map successfully. As an example, read from an empty file. Then there should be an error that comes in. An exception gets thrown, and this is probably not going to happen, some weird map exception. And then the map was successfully filled, various labels attempted, user input is shown in yellow. So here's some examples of some output. And this is a good example for you guys to use for testing as an example, so that you can try this kind of stuff. You should get these outputs when you try the distance formula and so on, or approximate outputs. Okay, might not be the exact numbers, but close. Program requirements, section 2, you must use your main, and you set up how you implement the features that are detailed above. It's up to you how you implement it, but I also recommended some sections where how you would do stuff. Okay, that's what I kind of implemented there for you. General requirements are the same. So again, some kind of internal documentation. What that means, some people are confused by when I say internal documentation. It means comments, guys. Use comments. And then share your files on GitHub. That's important as well. We talked about that. And then, of course, there's the short video that you'll be using. Again, no more than 5 minutes-ish. If it's a little bit outside of 5 minutes or a little bit under 5 minutes, it's okay. But don't make it 20 minutes, guys. I'm not going to look at a 20-minute video. All right? And then submitting your work, a zip archive of your program files uploaded to DC Connect, a working link to your appropriately named GitHub repository. It should be named properly, so not some random name. And a working link to your demo video posted on YouTube or another streaming provider. Please try not to upload a video file on DC Connect. It is very long to download. Okay? This is your stuff. It's due on Sunday. Any questions before we move on? I know there's going to be, and you know you can reach me on Discord. So worst case scenario, as an example, if you have a bunch of questions on this one, because this is probably the most tricky one that I've given you so far, right? That has been created by Tom, right? Not me, Tom, but the other Tom. And it's tricky because there's less instructions and there's more expectation now that you've built some additional capability. I know, Nick. It's okay. You can reach me on Discord as much as you want. Sometimes I won't be available, like if I'm teaching, but for the most part, if you reach out to me, I'll try and get back to you within a reasonable time frame. All right. So I'm going to move on from this. This is your Lab 5. That's again due Sunday. I've kind of gone through the details. I'm going to close this application down here. Again, this is the way I just wanted to record how to do it. If I want to calculate the distance, but this is not the kind of the solution. There's much more to do here than just something like this. All right, so let's get into the next part, which is I want to talk about how to make a map, how to use the map structure. Okay. So I'm going to pull up the little structure that I've given you, right, as an example, and let's. I'm going to close this down for a second. Inside of our lab, the lab itself, right? So if you look up here, I've given you a, not the lab, inside of our in-class exercise, right? There is this starter project. I want you to download this one now, ICE 6, right? So in-class exercise 6, okay? So let's do that. I'm going to do the same thing for me. I'm going to pull up 6. Hopefully it's going to work for me this time, or I have to download it. I don't know. Let's see. Here it is. ICE6 is a more complete example. It has the same vector2d class and the vector3d class that we used last time. All right. However, we don't need to use vector3ds in this case, right? But I have them in here just in case. All right, just for our example. All right, so let's go to main. We're going to go to main now. And again, this is something that you're going to be handing in. So what we should do is, before we go anywhere with this, let us create the structure. So I'm going to go to Team Explorer, right? And under bottom where it says add to source control, let's add to source control, Git. And under my Team Explorer, I want to go to publish to GitHub. I want to do that right away with you guys so we can get this done. So publish to GitHub. And I'm going to look, of course, under Durham Programmer. That's where I'm going to put it. It's going to be called ICE6, right? It's going to be up online so you can follow along with me if you can't, if you're not quick enough to follow. All right. And I'm going to publish it. And then we're going to host this thing. So when I go up on github.com, let's go here. So github.com and then Durham Programmer, you're going to see that there's ICE6 up here as an example. Okay, so we're going to start with this thing. I want to grab this link and put it inside of our DC Connect. So whenever you go here for your in-class exercise as an example, you'll have the in-class exercise as practice, the video. Sorry, the link here. But one thing I wanted to mention is this. Please don't give me back my GitHub repo. This is not the exercise. The exercise is you practice so that you're better at it when it comes to you doing labs and so on, right? So this is our week 7 GitHub repo. Okay, that's what it is. It's going to be here underneath the in-class exercise subsection of our week 7 content area. Okay, right here. So you can always go through here. If your code doesn't look like my code, or if your code doesn't work, just check here, and then you can see what I did. That's what it's for. All right. Let's continue now. So I want to do some stuff. I want to wipe some of this stuff away. So I'm just going to comment it out because we don't want to create a vector of type game objects. I want to create a game object map this time around. All right, like I talked about before. So how would that work when it comes to the map structure, right? So again, let's comment it out. And let's suppose that I have a map structure. So I can go standard map, right? And I need to say what type it is. I want it, here's what's happening. Notice it's kind of saying, hey, Tom, are you sure that you want to do this? Resharper C++ will give me some hints saying you may want to include the map include. And I say, yeah, sure, I think that's a good idea because otherwise I can't use a map unless I include it. All right, that's the first step of using a map. Cool. All right, so here's our map. That's awesome. A map of type what? A map of type game object. I don't have to make it a game object pointer map, but it has to have the game object itself that's going to be stored, and then some kind of standard string. So a friendly name for the game object. So standard string as well as the game object itself. We're going to call this game objects. Okay. Does this make sense? So the map is indicating the key value pairs. So map is made up of key value pairs. Okay, in this case, the key is a string and the value is a game object. Don't worry about what the game object is, our custom type, right? That's what we want to put in there, right? Right now, this thing is empty. That's what it is. Let's add some game objects, right? So let's say, for example, I have a game object. Remember that what we have in the game object itself, right? So inside of our Solution Explorer, if we go to gameObject.h, game objects have the following thing, all right? They have a transform, a position of vector2d floats. That's what they are, right? And they have an integer, which is, it's called ID. Let's make another thing that all game objects have. Maybe they can have a friendly name, all right? So instead of just an ID, we can give them a friendly name as well, right? So I'm going to modify my game object class to include a name, and I want getters and setters for that, all right? So I'm going to say int is my ID, and name is of type standard string. So I'm going to say standard string m_name, all right, is what I want in there. Of course, vector 3D extends vector 2D. It uses vector 2D inside here in some sense. So because it includes vector 2D, it also includes the string itself. String I don't have to include, but if I wanted to, let's say I was nervous, and I said, I don't know if I have string, I can just include string here, and it's not going to cause any harm. Okay? I need getters and setters for this thing. So here's accessors, right? So I'm going to say it's going to return a standard string, and it's going to be get name. And I'm also going to set a standard string, which is going to be called set name. So set name, and that'll be a standard string name. Okay. Get name and set name. Cool. My constructor function only takes IDs though. That's all it takes. Right now it only takes IDs, right? And I want to have all these work, plus I want another constructor that takes a name. So I want to take another one that has a name, standard string name, and then plus the other things, plus all this, right? Instead of maybe instead of a vector 2D, actually that's pretty cool. Maybe I'll make two more. So this one of these, it does this, and you know what? I'm also going to take. So I want this type. I'll be okay if I actually make it properly. I want this type of constructor, and I also want a constructor to take floats instead of vector 2D, just to give flexibility, right? So again, I want a constructor to take floats, so I'm just going to grab these two things this time. So there's two more overloaded constructors that allow me to do different things. Cool. We have to modify our game object, and I'm creating this for you really quickly in order for you to see how this works. Okay, so now what I want to do is I want to go and I want to generate definitions by declarations using Resharper C++. It's going to do that for me, and it's declared a couple of additional constructors plus my get name and set name. Okay, guys, I'll be right back. I'm just being called away. 1 second, please, if you guys can catch up. Let's do that first. I'm going to show you what I did here. Make sure you have this structure for your game object before I come back. I'll be right back. Sorry about that. That was weird. All right, sorry about that. That was a little strange, but we're back. So hopefully you've done all this by now. Let's just get a show of check marks if you're with me. Check mark if you're with me. X if you're not. You should be all with me. I see a hand. I'm not sure what that means, but I see Daniel's put a thumb up. I'm okay with thumbs up too. And there's some people that are not responding at all. Please, guys, make sure you try and follow along. I think it's a good exercise to make sure you guys are good. All right. Thank you for that feedback. We're going to continue. Okay, so yes, we have this going on, and we've got our positions here and everything else. Let's fix this up. So again, a couple things. Let's fix up our previous constructor to make sure we have everything proper, right? We didn't establish what the name is. So by default, I'm going to say that the default is going to be m_name. I'm going to put a name of unknown. Right? So if the name isn't entered, I'm just going to enter a name unknown. All right? As an example. And same thing with our name here. I'm going to set the ID as ID. If you don't enter the name, if you use this constructor, we're going to say set name to unknown. So just kind of a placeholder. Right? Or we can also say, instead of unknown, we can say not set. Not set. So that way we can set the name if we want. Same thing with here. We can set name. All I'm doing is updating the previous constructor so that they include some kind of initialization for the name that we're setting up for our game object. Okay. Okay, now for this one, notice there's some marks here. It says string name. Well, I want to enter it here. It's going to say initialize field m_name from the constructor parameter. We can do that. It also says, it's asking me to do this kind of initialization, right? And I'm going to do that. I'm going to take all this, right? And I'm going to put that in here. So I'm going to do some initialization for this, but we have to be careful on how this is done, right? So mid is equal to ID. mname is going to be equal to name. We're going to see there's going to be a problem here in a second. mPosition, right? And in terms of float x and y, right? Well, it's going to equal to a new vector of x and y, right? That's what I'm adding in there. All right, so that kind of takes care of that. It says that, well, name could be const. That's for sure. And also, you know what? It might as well make it a reference, so we don't like copy the entire thing there. And then it also says, you know what? Maybe we want to pass by value, so we're going to use the standard move mechanics to pass a name by value, as opposed to or a reference by as opposed to pass by value. So that's what this does here. So that took care of the second this new constructor we just made. ID should also be a const, so should our x and y. Okay, like so. Notice I did it differently this time, right? I could have done setting ID, name, and position. I could have done that too. And maybe I'll do it differently the next one. All right, so, or I can just use the standard initializers. If I have all the details, then there's nothing that stops me from doing this. So I can kind of grab all this time and put that in there, name, ID, and so on, the position, and instead of x and y, I want to pass in the float. So my position is going to be this position right here. I can just pass in position here, right? Because that's something I can do. It is already a vector too. I'm just passing it in, right? Here, this should be const. And again, I'm already doing these move mechanics, so I don't have to do anything else. Get name and set name. Let's just figure this out. So get name is going to return m_name. And that should be probably const. It's going to ask me to make it a const function. Again, this is all review, guys. And then set name is m_name is equal to name. It's probably going to ask me to do by reference. I'm totally fine with that. So add a const, right? Make it by reference. And that's pretty cool, right? And it says that should be good enough. Cool. So that is modifications to the game object. So why did I do that? Because I want the name to be associated with the key. That's why. Right? So when we set a name, I can search for the object by name now, as opposed to by ID. All right? So I'm going to save this, save this, save this, and put this up on GitHub. So how do I do GitHub again? I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. I'm going to say that I modified or updated. We'll say added name field to game object. Right? Commit all, home, sync, and push. And that'll push everything up to GitHub for you so you have everything that I have. Cool. So we've got game objects. Game objects now also include a type of name, right? So when I load a game object onto this, let's declare a new game object. We'll say, okay, hey, game object, I want to make a game object called ship, right? And let's establish what ship is. I can say ship. Well, that is I can use one of the 4 constructors I created. I want to make a ship that's called ship, right? The ID that I can put in is 1. So it's the first, or maybe we'll make it 0 if I want to keep track of the ID. And the vector2 object, I can put X and Y coordinates, or I can use a new vector2. Let's just put X and Y's. So I'll say that it is, I don't know, 3.0F and 4.0F. So that's the ship itself. So that's a new ship. Let's make a couple other objects. We'll make an enemy. So we'll say we're also going to have an enemy object. And this will be called enemy. Again, my object is complex. It's not a standard object like we're gonna pass in here yet. Okay. And instead of being in the exact same location, we'll make it so that it is the values we showed you before, which is 10 and 20. All right, so kind of a larger example. There's no pointers here, which is a good thing. Okay. Cool. I got 2 objects. Now I want to add them into my map, right? So I could do it manually. I could say game objects, and then the friendly name of the associative array. I could say ship here, right? Could do this. It is equal to ship, right? So this is a way of associating, creating an association between the key, which is the ship, and the value, which is a reference to the ship itself, the object. All right? And then I could say game objects enemy. This is my own. I mean, I can make whatever I want here. And I can make this equal to enemy. Okay? So ship and enemy, no problem. One thing I'm missing in my game object .h. Is there a toString? I think I do have that. Let's go into that toString in my game object.h. Go to definition. ToString says ID in position, but it doesn't really classify. It doesn't show me my name, right? And just like we've done here, ID, name, and position, I want to do the string that says ID, name, and position. Let's do that. So we'll say output string plus equals to, because we want to kind of add to our string. We're going to say that name, right, is equal to what? Plus our name, which is get name. Okay, plus \n. Okay, so I'm going to print out the name as well. So every time I loop through, I'm going to print out the ID, the name, and the position of the ship. Okay, that's what or the object that I'm going to print out. Okay. Let's go back to main, and now let's create a loop. So I want to be able to loop through these things, but I need an iterator, don't I? Or can I do it another way? Can I make a for each loop or a for in, right? Some kind of for loop, right? A range-based loop, right? So for my collection, in this particular case, my collection is going to be my standard game objects map. I'm going to use the type is going to be auto, right? and the element is going to be called game object. Let's call it game object like this. So game object. So for this, the way you read this is, for every game object in game objects, loop. So loop, keep looping for every game object in game object. So then I can access the game object itself. I could say something like standard cout, and I can look at the game object. So I can say game object, this one, and I want to print out the key, right? So remember what this is. Look how I have first and second, like we talked about it in the PowerPoint. So I can say first, all right, and that's the key. So we can say key, right, first. And then we'll do the standard cout value, just so you can see the key value pairs. Let's space it out so it looks nicer. Which is game object dot second, right? But think of what I want to do here. Dot toString, because I want to convert second represents the actual object itself, right? Now, if I had some kind of overloaded output operator, then I wouldn't have to do toString. I could just use the overloaded operator. Do I have that with GameObject.h? No, right? I don't have a friend. I would have to make a friend class here that could call the toString function. But here I'm just doing it manually, right? So here we go. So I'm hoping that when I loop through, it's going to go through each of the objects that are inside of my associative array, go through it, and do this kind of thing. Let's run it. Okay, so this is what I got. It says key enemy value ID 0 name, and then key ship value ID 0 name. Okay, what happened? I'm not really getting my name somehow, right? What's going on? How come that's happening? This is okay. The position and the position is okay, but my name is being lost, right? It's not printing it out at all, actually, right? And my value seems to be wrong. Look, my value ID is 0, and my value ID is 0, right? So let's see what that looks like, okay? So value ID is what I'm looking at, right? Second.toString. So let's go to that method, go to definition. It's going to take me to this toString method. It says getName. So, okay, where's getName? Right? Set position, right? Set name, getName. Okay, cool. I set my position through these values up here. I said, well, I want to take my name and I want to move it to name, right? Well, this is wrong, actually. It should go to m_name. Well, no, sorry. Name should go to m_name. Somehow this didn't work. This move operation that I tried to do did not get stored somehow. And ID to ID also didn't happen, right? Because ID also became 0, right, by default. So what if I try and use, instead of using this, because my constructor function did not work, right? What if I try and do it the other way around? And tell me why I would have to do it this way, guys, if I had to at all. So let's go and do this way. So this part set, but not this. Somehow my IDs didn't work at all. It's either something's messed up here or I did something wrong. So let's do this first. So I'm going to do it the other way around. All right, so I'm going to say that let's set position. Oop, this one should be this one. And this one should be down here. And you know what? Let's also do a name as an example. So set name instead of set name not set, set name is going to be name. Okay, and what I want to do here is do const, and I want to do the ampersand only. I don't want to do the move semantics. Okay. All right, let's see if this is any better. If I've got a better kind of step in terms of what I'm doing. So set ID, get ID. This one has an extra curly brace I don't need. That's causing an error. All right, let's see if it works now. How that, did I make a change? Did I mess up? Something goes wrong? What's happening here? All right, let's go back to this and rerun it, because my expectation is that we should see a better output. But oh, what's happening here? Okay, well, let's test what's going on in here. Maybe it's not me. Maybe it's something that's happening when I put it into the map. So let's do that. So let's go over here and just go. I want to do a cout, standard cout, and then the ship.toString. So directly, I want to do this. And maybe this is a problem with the ship. Maybe not. I want to know what this is. I want to see what my toString does before I put it in there. All right, so let's put this out. And it says name is ship. What? How do I have name ship here, but here doesn't work? How come? What would you think? What would you see might be the problem? So game object .second .toString doesn't seem to work. I got some of it, but it's not passing out the string value at all. The string works because when I do this, when I just do the regular operations, right, I'm getting ship and 0. And if I was going to do it for the other one, let's just say instead of looping through it this way, right, let's do standard cout, and I do enemy .toString, so individually. I'm just looking at the time here to make sure you guys, I respect your time today. And let's see how this looks. Look, I have enemy an ID of 0 because I set it to 0. Let's make our ID 1 just to be slightly different. So ID 1, which makes sense. And let's go in there and do this. Okay, so we can see that my ID comes through, no problem, enemy and ship. Notice that it didn't go in any particular order. When I looped through here, it didn't do ship and then enemy. It did enemy and then ship when I put it out. Why? It's going to do it in sequential order according to the key. It's a sorted list, my friends. But the name is what I'm really worried about. How come the name is not coming out, but it's coming out over here? Right? Why is that? Okay, what about instead of making my ship objects the way it is right now, instead of making them a game object, I made them game object pointers. Okay, game object pointers. So when I define a ship, then I'm going to make a ship, which is a pointer object, right? So I want to use the new keyword, equals new game object. That's how I can do the new ship. So let's say, for example, I want to make that new game object enemy. I can allocate dynamic memory, right, to do this. These are going to be pointers, right, now. And I can't access enemy toString or ship toString anymore. It's got to use the arrow function. So ship toString, enemy toString. Okay. How about we do it right? And then when I do ship an enemy, it still computes, right? Except this is no good anymore, right? Game object, second, and then it's got to be dash toString. This is how that would work. Is this going to give me any better results? Let's see. And by the way, game object itself, it says, hey, you know what, Tom? Maybe what you want to do is do a C language tidy fix to use ampersand auto, const auto for you to do this. Okay, let's see if that works any differently. So yeah, right? Look at that. I've got pretty good access there as opposed to before. Yes, the map declaration is an important piece, right? So that works beautifully. When you have a complex type, pointers work fantastic. Why? Because I have a complex type instead of a complex type, which is a string, and I'm returning out the type of string. It works great when it comes to this, but because of the way I'm doing it, the proper way to do it for me to get an output of my string, my second toString, is I have to overload. Chances are, if I overloaded the output operator, would be better. Okay, there's a danger in doing this. This works great, but, and by the way, it tells you, hey Tom, maybe what you want to do here is you want to use the keyword auto instead of working so hard. And you know what? They're not being modified. You might as well, Tom, make it so that it is, a auto star. That's the new way of doing it, right? When I've declared these two objects of type of game object, right? Cool. And I can add as many of these as I want. But what if instead of just making my keys whatever I want, this can be lost. I want to put my key as the name of the object that I've already declared. Well, I can do that here. I can say that I've already declared ship. So I can say ship name, right, is what I want to put in there. And I can do that too, because the map doesn't care. As long as it gets a string out, because I'm looking for a map of string game objects, then I can do that, right? So I can say an enemy get name. All right. By the way, if I'd use get name over here, it would totally work, right? So this is pretty cool, right? And let's see how this works when I set up my key value pairs. Will my key value pairs be the same? Let's see what happens. So yeah, look, my key is ship. My value is ID. ID is 1 and 0. By the way, value, the reason why it looks so funny is because really value should be like Zo. It should be an end line, right? Something like that. And we should probably have some kind of decorator that looks like this, just to give it an idea of what the value is, right? Because we can't tell what the value is otherwise. It looks weird. Okay? And then I can do this part. Actually, just do one of these. And maybe not so many spaces. Something like that. Space. No, that's probably good. Something like that. All right, let's see what that looks like now when I loop through each of the values. Right? So here's my ID. Key is the ship. The value is all this stuff. Okay? And maybe this is no good. Because it only works for the first one, but not the second ones. And maybe we can even be a little bit less fancy and just take this back here a little bit. Again, I'm just reiterating here so you can see what it looks like. So there's my key, the ship, enemy, my name, and the key and the name of the object is the same. I want to find the distance between the two objects. How do I do it? I can do that by saying something like auto distance, like I said. And the distance would be the distance. I'm going to use a vector 2D float type. And I'm going to say the distance between game object 1 and game object 2, which is ship, right? And it's ship get position and enemy get position. Okay, I want to find the distance between these two objects. I can do it this way. As an example, I'm using pointers here. And then I want to print that out. So I'm going to say distance between, again, we can look at the map values. What if I wanted to use the map? So I want to make the game objects ship. I can do that too. I can say game objects ship, game objects, right? And I can say ship, get position. That's how you'd access an object inside that's stored inside of the map, right? As well as enemy position. Makes more sense, right? That's why associative objects like this, like maps, are awesome. Because I can look at the object. It looks like a game object for me, but I can tell which one it is. The one that's stored as a ship or the enemy, right? Distance between the, right? We'll say the game objects ship, get name, and game objects enemy get name, is distance. And we'll push that toString just to make it compatible. toString. Sorry, I'm going a little bit outside. I'm just gonna cut it in half so you can see it all. Just on 2 lines here. Okay. So I can find the distance between 2 points, but I'm using the map, not the direct references. These are the direct references, right? But maybe if I'm loading it onto another file somewhere, I don't know which ones they are, and this is a great way of doing that. Let's run this thing now and see what I get. So it says, just like we saw earlier, the distance between ship and enemy is 17.464249 units, whatever that means. Pixels, kilometers, kilograms, whatever. It's up to you. Okay, and you can see all the data that I have in here. Pretty cool, right? Okay, I want to store these things on a file. As an example, how do I do that? Well, I need some kind of file operations, read and write operations inside of my structure here. I've given you a map for this kind of thing. Notice that in order for me to do a file out, let's say output to something, I need to open up an Fstream. Okay, that's what I want to do. So let's do that. We're going to say that just in here, we're going to say that, and in order for me to open up an Fstream, I need Fstream and cstdlib for exit functions prototypes, right? So Fstream is up here. Let's do that. And include also cstdlib, right? So I included those 2 things. This is right from the PowerPoint, guys. And then I want to do Fstream. I'm going to call it, it says it's calling it out client file. We're going to call it out game objects. So Fstream. And by the way, can I use Fstream or do I have to use standard, right? Standard Fstream. I'm going to declare a type, which is going to be we'll call this the out file, the output file or whatever. And what I want to do is, just like it shows here, I can use the constructor notation, whether it's this or this, it doesn't matter, right? It's the same thing, where I want to pass in the name of the file and the type, the way I'm going to do the operation. So I'm going to say the name of the file is going to be the gameobjects.txt, and I'm going to do a standard iOS out. Okay, I need to do it this way because, remember, I'm not using standard. All right, and sorry, let me go back to that. So first thing I do is this. Then what I want to do is I want to output. Okay, I want to output somehow. So this is write operations. So here I'm checking to see if my program has got a problem. Yes, I want to do that. I have some stuff that I declared, and then while it's this, I want to get information, and I want to get from my object out to the file. So when I write out to the file, remember what I'm doing, right? There is no standard way of writing out to the file. I want to write out in sequential order. So let's say something like, and by the way, I haven't closed the file here, right? I'm not doing that. So if it says not out client file, then if it doesn't exist, as an example, if I'm unable to create the file somehow, that's what this gives me an error, then I'm going to do that. So I'm going to say just something like my out file, and I want to pass in the name of my game objects right now. So let's try this. So again, I'm coming out from, and bear with me guys, I know I'm going to run a little bit over time, but I want to make sure that you have some examples of this so you can use it for your lab. So I want to output the positions, right? So I want to get my ship position, right? Can I do this? And can I also do the next thing, which is my next position? Let's try this out. So I want to output my enemy position. All right? And what does this do? Right? Does it work? So let's run it. And it says distance is blah, blah, blah. Everything is good. Okay, cool. Let's see if I got the data file. So I'm going to right here, I'm going to add in a new filter. Let's add a new filter here that's going to show data files. And I'm going to right click and I'm going to add existing item. And I'm going to see if I've got a data file that says out file. Do you see a data file here that says out file? Did it do the right operation? Did it complete? What's missing? Right? Notice that I don't have it here, right? Please be careful where it's being written. Is it in debug? No, right? Is it in this? Right? Where is it? If it was written, then we would see it because it's looking for all files. All files. Look, there is no data file, guys. So somehow the right operation didn't happen. Oh, yes, it is. Here it is. I'll be okay. All right, cool. So gameObject.txt. Let's see what happened. Did it go? Look, it did. Right? And it printed it out as a thing. So it wrote up to the file. Right? So that's how you can write to the file.
Sorry, how did you get to the file explorer? You right-clicked on data files. And
right-click on data files, and I said add existing item.
Okay, thanks.
Okay. All right, but what I really want, I don't want this. I want more information. And when I'm writing to a file, it's called serializing. I'm serializing out to the file. And now what I want to do is I want to deserialize and pull back in from the file eventually. Okay, but first let's serialize. So I want to put my position, and I also want to print out my name, right? So I want to take this exact thing, structure, and put it back in there like again. And instead of position, let's say get name. So I'm going to put the name and the position. Okay, name and position. And we'll do the same thing here. Kind of do this. And we'll say name and position. And if I run this now, right, it'll write things out back to the file. It's destructive. So what it shows me is now the ship and the position. So the name, position, it does both. If I want a space in there, so I want to serialize it so it gives me a space, then I got to add it in. It's not going to do it for me. I've got to create the way the file it looks. Okay, this is the way the file would look when I send it out. If I also want to create an ID, I'm using this as a delimiter, right? I want to use the ID out as well, so the name, ID, and position, something like that. Then I can do that, right? I can just kind of go out here. By the way, here's something else I can try. What if I want to try toString? How's that work? So instead of, I can save myself a lot of effort maybe. So I'll say my file, my ship, and then toString, right? And my enemy, toString, right? Will this be okay if I did it this way? And if I ran it, doesn't complain. And if I look at it, it looks like this. It's not a bad way of doing stuff, but it's probably, for a data file, I have extra information here that I don't need. okay? Because I'd have to ignore this part. I'd have to ignore it, right? So instead, what I don't want to do this. I could create something that allows me to write to a file. Guys, bear with me. I know I'm running overtime, okay? And read from a file. So in my game object superclass, my game object that I made, well, I'll call it a superclass. It's a class, right? I have a toString method, but I'd like another method, for to file is what I want, right? So for every object to file, right? So let's do that. So I'll make a new one, standard string. I'll call it to file, right? Const. And my to file is going to be very similar to toString, but just formatted differently, right? So I'm going to generate the implementation. I'm going to grab all this, because I want to still do some of the similar things that I did before, because I don't want to work hard, right, at all. I want to, output string is going to be equal to get ID plus a space plus my name plus a space plus my position. Plus a new line character. Actually, we won't even put the new line character. I'll let the person decide how they want to do that. It's just going to put a string out, no new line, just the string itself. So that way they can decide what to do. Okay? And of course, I'm using multiple lines here. I could cut this down into one line. I don't even need to use this output string at all. I can just simply put something that looks like this. So cut this. What if I just did this? Is that good enough? Can I return something that looks like this instead? Is that something that I could do? And yes, I could. I can keep it simple. So it's going to be standard string get ID plus a space, a name, a space, and the position. That's what I'm looking for. Okay? So let's see how this looks now when I use it in my code. I don't know why I'm doing that, but let's go back to my here, save, go back to main, and now instead of toString, I go to file, right? And let's see if that serves me better, because I can do it in one, right? Out to a file, and I run it. Same information goes out to a file. Let's see if it works. If I go to my gameobject.txt, beautiful. 0 ship, 1 enemy. And we're good to go. Why am I showing you this? Because I want to load it back in. Let's load it back in, right, from the file as if I don't have it. So I'm going to load it back in. How do I serialize now? So I serialized going out. I need to deserialize coming back in. So this is the way out, but I want to deserialize when I come back in. So again, I want to make a in file. Instead of iOS out, I want to use iOS in. That's the next thing. When I write, we're still using Fstream, but we're using the in client file or the in file, which is iOS in. So again, same idea here. Instead of an out file, we're going to use an in file. When you read, we're going to read the same file. iOS is going to be inbound, right? And my in file is going to spit out data into my game object. Let's make 2 more game objects, but they're going to be named the exact same way, right? So, and instead of doing it with a in game objects here, like this, let's do it directly inside of a map. All right. So we'll say that game objects. And we'll say the new game objects, we'll call it something else. So we'll say ship or whatever the ship is plus another value. So we'll say that we want to get an input for the first thing. I want to read all elements in my array, right? So look at the loop that they have here. They create a while loop while my input file, while it exists, right, as an example, I'm getting stuff from my file and I'm pumping it into my account and my name and my balance, right? Well, I want to do that. I want to kind of say while my in file, and I want to pump it into, by the way, I got to use standard here, right?
You just have a typo, missing the I.
Okay, thank you. My standard, I want to make it so that it is inside of something. I want to create something that it's going to come into, right? Because I want to read from something, right? But the problem is I'm going to put it into a new object, right? And I don't have that object yet. I've never created that object. So how do I read it into a map? Think about this. I can do a while loop and then read it into a map, right? What about if I just did, I want to read my in file, right, until the end. Is that possible? What would I put there for, I want to look until the end of file. I want to keep reading the in file until the end of file, right? While win file is not equal to something like in file dot, and you can see that there's some values here. Clear, you know, end of file would be something I want to do, right? So while not in file end of file, while it's not the end of file, then I want to keep reading. I want to keep reading from the in file. So I want to say in file, I want to create a new object. So I'm going to say game objects. And the new name of the object is going to be the first name of the, the thing that I'm reading in, right? So let's do it the other way around. Instead of using my name, right? Because my file is set up like this. My game object.txt, it's the ID, the name, and this, right? I need to skip my ID. That's what I need to do, right? Somehow. So I have that as a structure that I've put in. That's how I put it out there. That's how I got to get it in. I have to get it in. So we're going to make a temporary ID. So int will say ID is what I want, ID. And the ID is, we're going to set that to 0 just to iterate it, right? And we're going to say in file ID. We're going to kind of read from the in file into the ID, right? So why is this not going to work? Because look what it did here. In file, blah, 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 blah. And then here's my output line. So why isn't this going to work? So I want it to go into the ID. I declared it of type int. It says, so why isn't it going to, and do I keep going? Do I have to do this thing where I say int ID, let's suppose my name, some kind of name. Do I have to do this? Like it says in the example? And the last thing is going to be the coordinates. So we'll say vector 2D of type float, which is position. Can I do that? Right? Can I do position? Am I allowed? Can I do this at all? I mean, inbound out to the file is okay, but what about inbound, like towards me? What's wrong here?
There's no specifying. When we have to specify like the line break, so like ID and then space and then name and then space, and to ignore those spaces as like a divider.
I could, but so look at what output line does. Output line takes all the things, but here I'm not specifying anything. When I output to my file, here's my output file. I use my out client file as an example, while cin account name, I output all these things in a row and I add any spaces I want, right? When I'm outputting, I'm going out the or in the other way, then what I want to do is I'm going to go into, because it's going to be reading, right? It's going to be reading from the client file into account directly, from the client file into name, from the client file into balance. That's what this does. So I'm following the same thing. How come it's not working for me? Because you're going to run into this problem, guys. What have I done wrong when I'm doing infile? Here's infile, right? And I'm trying to read it from the file into my ID. So what is the error that I'm getting? First of all, it says no operator in matches arguments of type standard basic upstream car in int. I need to convert it, right? Because everything that comes from the file is a text object. Look how name didn't complain, but position did. Position is an issue, my friends. And the reason why position is a real issue is because I'm getting brackets. The way I've specified it, I've got these brackets out here. Look at this, right? This is dumb that I did this. But guess what? For your assignment, it's the same. You've got brackets in here, right? So when I enter brackets, I need to ignore them, right? I need to ignore the brackets because I don't want to see the brackets. I just want to see the values, right? That is an issue, my friends, that we have to overcome. We have to deserialize. We serialized on the way out. We coded it on the way out. We created a file. When we created a file in a sequence like this, we are serializing or coding it, encoding it in a certain structure. When we come back out, we have to deserialize and put it back into the structure properly, the same way that it went out. Okay? So this is fine, what we just did here, but we need to convert this into a string, all right? Some kind of string value, or so a string to I, STI. Can I do this? A string. So I want to do an so a string to I is what I want to do. String to integer. Is it a standard function? String to integer, right? And I want to pass in an ID, right? My ID, string to integer, because I want to convert from a string to an integer. But what's happening is it says no instance of overloaded functions S2I match the list of type argument are int. Okay, so maybe what I can do instead of this is I can just cast it as an int, right? I want to cast it as an int. And it says, nope, no operator matches characters of static base of stream character and int. I want to convert it from a character to an int. How do I do that? Well, that's true. Instead of stream, right, I need is stream. That's for sure. That's going to help me because that's going to declare this. That's another error, right? But this isn't not going to stop me from doing this. That's just this one part. What's the other one? Convert from a character to an int. How do I do that? Okay, let's look it up. Come on. Character, so C++, character char to int. How do I do that? I'm doing it, right? Int IA is int of A. I got a character and I'm taking this thing in and I'm converting it, right? So I'm doing this, right? But it's like the input that I'm getting from a file is already a character, right? As an example. So here's a thing that we could do. We could read, this is a stream, right? So the stream is inbound, right? And I want to convert this stream to an integer. So again, we can look at something else when we're looking at it. You're going to have the same searches. So convert if stream to int. How do I do that? C++. So Okay, I've got an integer xp and xps into xp, right? It says if so, all I have to do is use the operator from the if stream. Well, we just did that, but it didn't work. So what happened? It's not working. Well, it would have worked if I had used if stream in the first place. Okay, but now this is a problem. This is a real big problem. My position can't be, I can't input from my position. I need to skip. How do I do that? My position will not compute. There is no way of getting my X and Y in there, right? And I also have some extra information that I don't need, right? So what do I do in that case? How do I skip or ignore my in file, right? So could I just do something like we did before, in file, like an ignore? We did it last time. Like here's an example of that in our vector2.h, right? Sorry, in our vector2.h, yeah. We have our, when we're inbound, we can do the ignore function. Ignore something. Can we not do that here too? Is that possible? So can we do ignore? Right? Could I? Can I ignore a character while I continue to go inbound? Can I do that? And it says that call of an object of class type without appropriate operator or conversion function is to pointer to function type. It doesn't know what I want to do. So again, back to the drawing board. Ignore, character from if stream C++. How do I do that? Well, I'm using the ignore function. Okay, cool. Ignore function reads and discards characters from the input stream. That's what I want. So give me an example of that. Right, well, here's my input stream, right? And in.ignore. And I can ignore one character. I can ignore however many characters I want. Can I do ignore one? Well, it's not really working, is it? So what's the problem? I mean, it shows if stream here. Here's in.
Don't you have to specify the characters you want to ignore?
Do I?
Maybe.
Well, look. It says ignore up to 10 characters or until the first space is found. That's what this does. And then I get each character, one character at a time. And then if in, then I'm good. But how do I ignore, right, the stream? Should I do it on the next line maybe? So in other words, I've done all this, right? I've read the name. And then what I need to do is in file dot ignore, right? And I want to ignore one place, and then I want to input into my position. So let's do a new line just to be clear of what's happening here. In file into my position dot x, right? But oh man, what? I don't have access to the x, right? I can only set x, right? I can't, it doesn't allow me to do that, right? I've never done that stuff. So what I could do again is create x and y temporary variables. So we'll say int id, right? This is x and y. They're all set to 0. I can do that. And then first I'll read everything in temporarily, right? I have to also ignore infile.ignore the next thing I get, because that's the comma. I don't need the comma, right? And then I want to infile into the y, right? And I want to infile ignore the next thing that I get, because I'm going to get extra pieces of information I don't want, right? Okay, now that I've input everything that I wanted, actually I probably don't even need to do this because I don't care about the last character. But anyways, so I read all this stuff in. Now I got to formulate my new game object. I got to recreate my game object. So I could do a couple things. I can make a temporary game object, right? I could do that. So I can say game object, we'll call it temp object, right? Now if I'm going to put it into my my map, it has to be of type game object pointer, right? Has to be, because that's how I declare my map. is a new game object. I'm going to pass in the ID, right? And I think I did name first. Name, ID, right? And then my X and Y coordinates. Does that make sense? So I'm reading it in temporarily, I make it, and I can call this auto because we don't know what kind it is. There we are. So I make two new game objects, right? Temporary game. So I make a temporary game object. And now what I want to do is I want to take the temporary object's name or just the name itself, add, let's say, something to it. So because it can't be the same as I did before, right? So I can say something like game objects, and I can say name plus 1, because we don't want to make it the same name, otherwise it'll overwrite what we had before, is equal to temp object. Okay, in this contrived example. So we'll have ship 1. Well, actually, we'll make it 2. So ship 2, enemy 2. All right? That's what we'll get in here with the same information. Okay? And now we know that it says we're getting these little curly braces. It's a narrowing conversion from int to float because we're getting integers in, right? So let's make this what it should be. So we'll say that this will be int and this will be float. Okay. Okay. So it says that there's 5 overloads. It says this one, the ID. It says narrowing conversion from float to int. Name, ID. Did I make my ID an integer or a float? Integer? What the heck is it talking about?
You just mixed up. The X and Y should be a float, and the ID should be an int.
I'll be okay. Thank you. That's what happens when you're coding live. There we go. And what does this say? It's probably going to ask me for to make it const. Rename. No, it wants me to rename it to temp object because of my naming conventions. Right? There we go. All right, so that should work, right? I should be able to read everything in, and if everything goes well, I have it. Then let's print it out again. So we'll do like kind of a loop again, the same loop. Again, we can make functions for this, but we don't have those functions. And this will be the end of what we're going to do today. And I want to print out for every object now, let's output what it shows to what it shows. So we see full circle. All right, let's try it and see if it doesn't fail. And it says key, blah, blah, blah. And it's reading and reading and failing. See how it's going, like it's going like this? That is an error. That it's continuing to read forever. Which means it's either never getting to end of file. Let's go to my end of file for a second. So what did we get in our game object? We have this. But somehow it's never getting to the end of file, right? It's never finding the end of file. So our while loop, right, going back to this while loop, not in file, end of file, right? While it's not end of file, it's going to keep reading, right? So we can position this a little differently. We could say that we can put all of this. Again, I'm trying to be smarter, right? But the problem is when we do this, we have to do this part. We can't just read stuff in because we need to do some ignores, right? So let's see, read, while loop, read till end of file. So while loop, while read to end of file, C++. Right, and see if there's some kind of thing like that. End of file function. All right, here's an example. If we assert while not in end of file, because that's file in, it's really terrible to see, then I'm going to keep going. Oh, and then we have to close the file. Right, well, this is important. We didn't close the file in the other way either. Maybe that's an issue. So we have to close the file going out and then close the file going back in, or flush somehow. So let's go back to our output file. Here's our output file. Let's close that file down. So outfile.close, right? And then what we want to do is when we hit here, We're going to iterate until we are at the end of file. Let's see if that works. We'll definitely want to close off the file when we're done reading. So that's going to happen over here. In file dot close. We're close, guys. It's going to still go forever. Okay, and you can see because the memory allocation is going over and over again, right? So that didn't work, right? So what's the problem? What can I do? So again, I'm reading, and what if I took away this ignore? Because it's going to keep creating objects, right? Forever. And that's why the memory allocation goes crazy. The memory allocation goes crazy because I keep on creating new objects. That's what's happening here, right? So what about if I don't ignore the last thing, right? Still no issues. It still continues. It's not the ignore that's causing the issue. It's this while loop, right? All right, so how else? So this didn't do it, right? I want to read until... So it says test condition true is only when there's something to read. Works nicely is and this works with getLine. All right. So I can say something like file in open. I can do it separately. We can open the file separately while getLine in, and then for sent, this is the object that's being sent. Right, so I'm actually getting a line here as an example, but it's inside my while loop again. So I'm only getting one thing at a time. Right? So this is getLine. Getting one line at a time, but I'm getting the whole thing inside sent, whatever that object is. Here's something else I can do. Right? I can read everything into a string and then parse my string. I can go through the string, and then I can say, okay, I've got my string stream. And then I can deal with the string separately after. Right? That's what I could do as well. So, because I need to do all this, right, in my string stream. I need to do kind of all this ignore stuff that I couldn't do in my file. Obviously my not end of file is not working. Right? And what I could also do is I could check at the end to see if as a hack, I could say if in file dot end of file, if that's true, I could say break, right? But that's kind of redundant. I shouldn't have to do that, right? I shouldn't have to break out of my file. And again, you're just going to see that it's not going to make a difference. It's going to keep going forever. Why? Why is this failing in file? Guys, I don't want to continue this too much, but so why would it be not closing down? What's the problem here? I'm not getting an error either. Yeah, right? It's not throwing an error. It's going to continue forever. Let's do a bit of a C out. All right. So I want to do a C out to show me when I'm reading a file. Right. I'm going to keep reading the file. So we're going to say standard C out. Right. Read. Read operation. Let's see if this continues. If I even get to down here, if it's something else that's happening, where I'm ignoring something or whatever. So I want to do this standard operation, right? So what's happening here? Let's see if that works. If I'm going to get what I'm going to get. Look, so it's an infinite loop that I'm getting. So let's keep on going here, reading, and it's not going to work, right? So this condition that I have in here, right, as an example, is no good. What I could do is, while I can still get stuff, that's what I did before. That it says that, hey, if I can in file and I can put into some kind of string, as soon as I can put into a string, and we can make some kind of standard string. Let's say standard string, and we'll call it in string, right? So I want to get everything into a string. While I can do that, keep going. And but when I do this, I'm going to lose data, right? So let's see how that works. So this one terminated, right? This one terminated. And this is what I got. Read operation. Key value to value 0. position, I got some wacky position here, right? Look at that. That first position was whack, right? Enemy, key enemy, ship, and I lost one in this whole thing, right? It did what I wanted to do. It actually terminated, right? So what we could do, right, is, and this is what you might have to do for your, for your assignment, is in my game object, or in this case in your vector2, the vector2 works no problem, right? So for example, I can, this is a complex object, right? And so too would yours be. Yours is a complex object that you're taking in, right? In my vector2, I do have an input stream. I do have that. I can do that, right? For my vector2. So I can say that, hey, I want to take in a vector2. It already has this ignore built in. So for the position variable, I don't have to worry, okay? For the position variable. My challenge is that what happens to the data, right? If I go back to this, right? It's going to read everything and then output it right away. Read everything and then output it, right? So I'm going to read account, name, and balance in this case, right? In my while loop. And that kind of worked. So I can kind of do the same thing, but then my problem is I also have extra characters, these ignores that I have to do. So how do I do that? What is a method that I could do it so I can read the whole string and then do something with it? Well, remember, I have this whole string. I can parse it afterwards, right? What if I made it a string stream instead? So if I said something like, just like we did in our vector2.h, right? In my vector2.h, we said that this out or in is a standard in stream, right? So I can make that what I want. I can say a standard in stream that's going to be in. So what if I did that for my thing instead? So here I can say a standard is stream, right? We're going to call it the in stream. In. Could I not do it this way? We'll call it in stream. Okay. And make sure that it is a reference, right? Why is this having a problem? Default constructor is missing. Of course it is. What can I do here? Typo and in stream. Sure. So I want to use an in stream. I want to do the same thing that I've done up here, right? So this is what I want to do. Standard is stream, right? Standard is stream. But I need the constructor function to do that, right? So maybe all I have to do is just declare it as nothing. So something like this. Doesn't like that. It needs standard uninitialized, maybe. Standard uninitialized. Or maybe just a character, like so. Yeah. So here's my standard in stream. And then what I can do is I can put this in stream in here. And why does not it like that? It says no operator matches type of standard basic if stream to standard basic is stream. Let's look that up. I'm trying to figure out a solution for you guys so that way I don't have to make new functions here, but I'm going to have to make a new function pretty soon. Right? Because I need to be able to overload my my game object. That's what I need to do. And this is what you may have to do as well. Well, I'm avoiding it, and I'm spending more time avoiding it than doing it, and better to do it than live with the fear of it, as they say, so let's just do it. So just like I did with my .h, I want to grab these two friend functions here and we'll declare, we'll do all this from my .h ahead of time. So we'll just kind of go in here. We'll do it inline for now, and then we'll get the information. So all I really need is with my string is the type of game object that I want. So this will be game object. Okay. And so the right hand side is the game object. I'm gonna do a right hand side toString when I output, right? So that's what's going to come out way. On the inside, this is the most important part to me. It's going to go into my ID first. So right hand side dot MID. Then I'm going to ignore the space. Then I'm going to say right hand side mname. Then I'm going to ignore the space. And I'm going to go into right hand side dot position. So again, it has a position m underscore position, and I can't do the setter or the getter. So I'm going to do by default, because I don't have that functionality. I could actually just do position. So same position. I probably could do this because position has that functionality. And then I'm going to ignore the last piece, which is my bottom part. And then I can do this. So that should do it. ID, name, and position. I think that'll do. Because position's already overloaded with me having my objects come inbound. Right? Because if you look at my vector2.h, I actually do this as well in here. So it should be kind of flowing through. Just go back one here, and I don't need my last ignore, but maybe I would for my case. I'm just going to leave them in line right now, and I can separate them out later. But I'm going to go here into my main.cpp now, and now it should be a lot easier. Instead of me doing this, I want to do for every game object, right? That's what I want to do. So I can say that I can make a new game object, right? And for every one, like a list of game objects as an example, I can enter the object in as an example. So maybe I'm going to make a new game object, right? And the new game object is going to be just like that. I need to put some values in here though. What if I just did this? So no new. But you get what I'm trying to do. I'm trying to read one at a time. I don't want to read it the entire time. So let's just do I'll do it the hard way. I'll say, well, I'm going to make a brand new game object. Let's try this. But there's got to be some kind of game object array or something like that, because I'm going to have more than one. So maybe I'll make a temp game object that'll read in, and then I'll put it in there. So game object, which will be temp. I'll do it up here. Temp game object. Right, and then I'll allocate some memory. New game object. I should be able to do that, and then pass into temp game object that stuff right there. That should overload. Did I not save it? Why not? Do I have to overload it differently? Because I'm saying basically it's the O stream and is stream. I wonder if I have to say it's the if stream. Can I do that? Can I overload the operator when it comes to an if stream? I can. And this will be it'll be an if stream instead of a in stream. But now my ID doesn't know what to do. The idea is good though. It's just that I'm having trouble with formulating it. Create a non-member operator that does that. So I just want to see what that does. Is stream and const int, a non-member operator. But I shouldn't have to do that. Const int. The idea is good. The implementation is challenging, right, for me to do. Because I got to do this. So let's take a look at an example for what my crazy head is telling me to do. So overload if stream operator C++. Okay, if stream ampersand if stream in complex character and this into this. This is calling the function infinitely. You don't want that to happen. Double real in real and then C1. Oh, okay, so they broke it down this way as opposed to. That could work. So in other words, what they're saying is do the hard work here. So int, we'll call it ID. So we'll do a one of these, right, where it does understand, it should understand how to do it in stream to ID. If this is thing, did I put if stream in here? Operator, let's comment this out for a second. Why is that giving me an error now?
I don't know if it matters, but yours is still if stream overload instead of iStream.
So yeah.
I'll be okay. But then that means that I would have to construct it. But if stream, no, it's if stream. Look, if stream and it's got to be if stream because otherwise it would be an iStream. iStream and if stream are two different things. In real double, and that should work. It says. What am I missing, guys? I'm missing something really dumb. Because this, instead of is stream, should be if stream. I wonder if I need the, if I don't have the proper include. That could be something I need too. Let's go into my main and see what I'm missing. I'm missing fstream to do that. And what's in vector2.h? I use sstream. And sstream should do it. So I wonder if I went to here, but although I have vector2.h here, so it should already have that information. Sstream. Of type int. So what's the problem? Standard basic string character and int. But I had the same problem and we conquered it inside main. We conquered it inside main by just doing this in file ID, because this is okay to do. In file is an if stream, right? Standard if stream. I don't care about this operator right now. We can get rid of this altogether. I just care about this one. if stream. Why is it doing that? Is it just a Visual Studio error? I don't think so. And it's not even giving me any hints. It just says create non-member operator. Let's get another example out there, because that totally should work. That's actually the example that was given. Right? Look. What about if I did that? If I say something like, so into rhs.m underscore ID, which is the same thing. It's an integer. And that it doesn't like that somehow. It's giving me the same problem. Int. Because if I did the other way around, Nick, if I went back to isStream, that works, but the problem with this is if I just did this, then in my main, that doesn't work. Doesn't know what that is. There is no conversion between ifstream and isstream. See? Can't be an if. It can't be an instream, right? There is no conversion between the two types, so it has to be an if stream. Oh. What? It has to be an if stream, huh? And this just a regular ID doesn't work either. Why is it giving me an out problem now? If stream, and it wasn't giving me an out problem before. I'm telling you, it's something to do with my compiler, man. I don't care if it errors out. Okay, I'm gonna try this one more time, and then I'll post a solution. A rubber duck? Sure. Tell me what the rubber duck. If it quacks like a duck and acts like a duck, I mean, is that what I mean? I'm getting the exact same thing. C1, same one. Okay, let's go to the next one. That is standard if stream operator greater than is read. Why do I have to use read? Character, reading a character object, read, and I'm putting it inside of object size of my int. Well, that's different. I've never seen that before, but let's try it. So if I said, what if I did that? If I said in read character game object or RHS dot m underscore ID of RHS m underscore ID. But that read operation doesn't make any sense, right? Because it says cannot resolve symbol read. So maybe there's something else. Fread. I'm telling you, it's so dumb that what we're doing, there's another way of doing this for sure. Guys, I'm going to stop. I'm going to post a solution instead of wasting all of your time and watching me struggle like this online. I'm going to find the solution and post it. It'll be in a message. I'll actually show you the solution right here. All right, for your in-class exercise, post what you have. All right, that's what I recommend. And then you have until Friday to fix up your file when I fix mine. Okay, I will post a solution. Not to worry. Bear with me. It says I've got some comments here. It says toString. Go to toString, right? That's not going to work, right? So I'm sure you guys are seeing it and I'm not seeing it. So I'm going to stop the recording now and we'll fix it and I'll post a solution later. Thanks, guys. I'll even post it on my YouTube video. So for people who are watching it on YouTube, you'll see the solution. Thanks, guys. Thanks so much. So I'm going to stop my stream.